In this video, we are going to learn about the deletion of an element from the end of a linked list, right? So let us consider a linked list with 4 elements. Okay, so let this be the first element. Okay, and this is now linking to the next element, which is maybe 5. Okay, now this is linked to the next element 6. Okay, and let 6 be linking to the next element, which is the final element in the list, which is 2, right? So this is the last element, therefore the link of the last element is made null. Okay, so you are also given the pointer, that is head, which is pointing to the first node in the linked list, right? Now your objective is to delete the element from the end of the list. So this is the element, right? Node with the element number 2 should be deleted, right? So your objective is to delete the last node. You have to remove this node from the list, right? So what you can do is, first of all, we'll create a pointer called as temp, which is pointing to the first node of the list, right? Now we may increment or we may advance the pointer such that it points to the last node of the list, right? We can easily do that. Make this temp pointing to the last node of the list, right? And if we simply perform this operation, that is, if I now do free, after moving this to the end, if I do free temp, what happens is, and it deletes the last element from the linked list. But this isn't sufficient, because now this is the current linked list. After deleting, the last element should have the link as null, right? So I need to place null, right? The link of last node, in this case 6, should be null, right? Now to do so, right, I need to have one more pointer, right? So what we do is, okay, let's take it back. This is the last element, so temp is pointing initially to this. Okay, so I need to have one more pointer. Okay, once temp points to the last node, I need to have one more pointer that is pointing to the second last node, right? Such that I can make the link of this second last node as null, right? So for doing this, what I do is, so initially the setup is something like this. Okay, setup is something like this, wherein temp is pointing to head, right? So you have something like this, temp is equals to head, right? Temp is pointing to head. Now I have one more node called as previous, which is initially pointing to null, right? So I have one more node called as one more one more pointer called as previous, which is nothing, which is actually pointing to null. It is pointing to nothing right now initially, right? Now what I do, my logic is quite simple. What I do is, I need to advance temp and previous in such a way that temp should be pointing to the last node and previous should be pointing to the second last node, right? So what I do is, I first of all make previous point to temp and temp point to the, I'll advance the temp to the next node, right? So I'll do something like this. Okay, I'll do while temp link is not equals to null. Until this is not equals to null, what I do is, I'll make previous first point to temp, and then I'll make temp advance to the next node, right? So I'll do temp link. Okay, let's see how it works. Okay, so first of all, I'll make previous pointing to temp, right? So previous is pointing wherever temp is pointing, right? So let this be head. Previous is pointing to temp, this one, right? And temp is equals to temp link. So link of temp is nothing but this one. So temp is advanced to the next node and previous is pointing to the one node previous of temp, right? Now go and check is whether the temp of link is not equals to null, right? The temp of link is not null because it is linking to the next node, right, with element number 6. What I do is, now I'll make previous equals to temp. So previous is here and temp is advanced to the next node, right? So far I have not made I have not made temp pointing to the last node, so I need to repeat it one more time. So what I do, previous is pointing to this one, right, and temp is pointing to the next node. Now this is false, right, because temp of link is null now, right? Now what I can do is, now I can simply free this node, right? I can remove this node from the list. So for doing that, I can simply do, after the loop is over, I can do free temp, because temp is pointing to the last node. By doing so, this will be removed from the linked list, so this is out of the list, right? And I need to make the link of, I need to make the link of previous as null, because this is the last node now. So I need to make the link of previous as null. So what I do, I'll make previous link is equals to null. So this is how I can, this is how I can delete the last element from the linked list, right? So now this is scenario 1, okay? This is the first scenario wherein, this is scenario 1 wherein you have more than one element in the list, right? So in this case you have more than one element in the list. We had 4 elements, right? Now will this particular logic work if there is just one element in the list? For scenario 1 this works well, right? Let's check whether this works well for a next scenario wherein you just have one element in the list. Now let us talk about scenario 2 wherein we just have one element in the list. So this is scenario number 2 wherein we just have one element, that is element with value 2 and link as null, because this is the last element as well, right? Now let's try to follow this setup, right? Let's make temp is equals to head. First of all, temp is pointing to head, so temp is pointing to head, right? And previous is initialized to null, so previous is somewhere here initialized, it is pointing to null or nothing, it is pointing to nothing right now, right? Now the first the condition inside the while, that is temp link not equals to null, is false, because temp link is actually null here, so it comes out of the while loop directly. So it comes out of the while loop because this is false, right? It comes out of the while loop, and what it does, it frees the temp, so it will free this entire memory. So this will actually be vanishing, right? This will not be there, so we'll actually not have anything right there. We'll not have head as well, right? Head is pointing to nothing then, right? So we actually need not do that. What we need to do is, in case there is just one element in the list, previous would be always null, because if there's just one element, this is not executed, right? This particular statements inside the while loop is not executed, hence previous will be null. So if previous is null, that means we just have one element. So in scenario 2, what we need to do, if previous is equals to null, you need to take care of this by making head is equals to null, right? In that case, what you do is you make head pointing to null, so you'll just make head is equals to null, then you're done, right? Head is equals to null, then maybe you can remove this, you can free this temp, right? Now we have deleted the element and head is pointing to the null, right? So this is scenario number 2, right? And you may have one more scenario, that is scenario number 3. In scenario number 3, you have no elements in the list. I actually have 0 element in the list. Right? If you have 0 elements in the list, head would be pointing to null. So in scenario number 3, if head is equals to null, if there is no element in the list, you have to display that this is actually deletion is not possible, right? You have to display deletion not possible, right? So for deleting the element from the end, you have to take care of 3 scenarios. This is scenario number 1, right? Maybe this one, take care of this scenario and this one, right? Now we can combine all these 3 logics in an algorithm. Okay, now we will see the algorithm actually which works well for all these scenarios. Now let's write an algorithm for deleting the element from the end. So let the name of the algorithm be delete from end, right? You are given the head pointer as an input. Fine. So first of all, I'll take care of the condition wherein the list is empty, right? So if head is equals to null, it means the list is empty. So I'll display deletion not possible, because if the list is empty, deletion is not possible, right? You can't delete anything if there's nothing, right? So deletion not possible. Else deletion is obviously possible. So in this case you have at least one element, right? At least one element. You can have more than or equals to one element in this case. So what you do is you make a new pointer called as previous, right? So what you do is you create a pointer called as previous and temp, right? Both the pointers. Now I'll initialize the previous as null, right? And I'll make temp equals to head, because temp is pointing to the first node in the list, right? Now what you do is you have to actually have a loop wherein you see compare temp of link with null. If it is not equals to null, you will actually make previous point to wherever temp is pointing to, and you'll advance the temp to the next node, right? By running this while loop, what you are doing is you are making temp point to the last node and previous point to the second last node. Okay, but there is one more scenario, right? That is, we'll consider it here. If previous is equals to null, if previous, which was initialized to null, is not modified, that means there is just one element in the list, then what you do is you just simply make head is equals to null, right? We have seen this scenario, right? Otherwise what you do, otherwise there are more than one elements in the list, right? What you do is you make previous, the link of previous, because previous is pointing to the last node now, right? Link is equals to null because it's with the last node, and you will free the node that is pointed by temp. We are deleting the last node and making the link of previous node as null, right? Now this should work. Okay, now in this you have to note that this is the scenario wherein you have just one element. This is a scenario for just one element in the list. Okay, so this is a scenario for more than one elements. and this is the scenario for no elements. Okay, now this logic would actually, this algorithm would delete the element from the end of the linked list. Thank you.